Hello friends, welcome back to my channel Edu Sanskara. So today's video will be for the civil engineering students. It is a very important part of the civil engineering students. So first of all, I like to introduce with the basics, and without clearing our basics we will not be able to solve the further problems. So in this video we will be covering the basics of the chapter, and then I will solve one problems related to it, and in the last I will give one problem for your homework. And if you have any queries regarding this, please comment me in the comment section. So today's video will be for the civil engineering students, and that is the beams. Beams. What is a beam? Beam is a structural member which is subjected to the lateral loadings, and we have to withstand these loads. So we need to calculate the reactions. So what are the reaction coming on the beam that we have to calculate in this chapter? So what are the beams? So I've told you beam is a structural member which are subjected to the loads which are right angle to the its axis. So beam is like this, and loads acting on it is a right angle to the axis of the beam. So these loads may be point load, that is a concentrated load, or uniform load, or UVL, that is the uniformly varying load, because load will be zero at some point and the maximum at the other point. So we will be studying all these in this video. So let's start. So first part is types of the beams. We have a different types of beam. Here we have first one is a cantilever beam. In cantilever beam, one end of the beam is fixed and the other end is free. It is similar to the overhanging beam, which is last one. Okay. Then second one, we have a simply supported beam. In the simply supported beam, we have the beams supported simply. Okay, you have only the two supports. And third one is fixed support. In the fixed support, we have beam fixed at both the ends. And fourth one is a continuous support, where the beam is continuous. Okay, where means in simply supported or other supports we have, I have shown only the one span. Here continuous support we have the more than one span. Then overhanging beam, I have told you that is it is similar to the over cantilever beam. So these are the five types of the beams. Then second part of the beam is the types of supports. We have a different types of supports, and according to the support only we will be able to solve the problems. But before that, I have to explain you two more types of the beam, that is the statically determinate beams and the statically indeterminate beams. So in statically determinate beams, what are the statically determinate beams? Statically determinate beams are those beams where the support reactions we can be solved using the three equilibrium condition. What are the three equilibrium condition? That is the vertical summation of all the vertical reactions 0, summation of horizontal reaction 0, and the summation of all the moments is equal to 0. So using only these three equilibrium condition, we can solve the problems, and it is called statically determinate beams. Those beams are called the statically determinate beams. And if we cannot solve using this condition, then it is called the statically indeterminate beams. So second part is statically indeterminate beams. In this chapter, we will be dealing only the statically determinate beams, so that we will solve using these three equilibrium conditions. And main part of this is we have to solve the support reactions. Whatever the support reactions coming, that we have to solve. And Now here we have seen the types of beams. Okay. Now second part of this is types of supports. Now we have a different types of supports, and looking at the support we have to find out how many reactions that support carries. So first support we have is a fixed support. So fixed support, in the fixed support, the support is fixed in all the three directions. So there will not be any movement. So we have three reaction in the fixed support. So horizontal reaction, vertical reaction and the moment. Vertical, horizontal and a moment. It is fixed, so there will not be any movement. So this is a fixed support. You have to keep in mind fixed support have the three reactions. Second one is a roller support. So roller support is denoted like this. You have to keep in mind what type of the support it is. Looking at the diagram only, you have to know what type of support it is. Roller support can be denoted this way also and this way also. So both the way you can depict the roller support. So roller support have only the one reaction, that is a vertical reactions, because in the horizontal direction it will move, so there will not be any reactions. Then third one we have a hinge support. What is a hinge support? Hinge support means it will have the movement, but it will not move in the horizontal and the vertical direction. So it will have the two support reaction, that is the horizontal and the vertical support. So, and the hinge support will be denoted like this. So this is a hinge support, and you have the two reactions at the hinge support, that is the horizontal and the vertical. So this is your hinge support. So these are the three types of the supports. These are the important supports you have to know. There is a fixed support, roller support and the hinge support. These beams is a basic, and it is also important for the mechanical students also, because it is included I think in the SOM subject. There is a structure of materials, it is included in that. And for the civil engineering students this is a very important topic. It is in the further second year and third year also it is there for y'all, that is in the structural analysis, and I think in the structural analysis 1 and structural analysis 2. So you have to know this basic first, then only you will be able to solve the next part. Then we have a types of loads. In the types of loads we have a three different types of load. First one is a point load or the concentrated load. Point load, it is a load acting at any distance. If this is a beam, okay, this is simply supported, okay, and point load is denoted like this, and it is located at any point, not necessary it will act at the center, it will be acting at any point. Okay, so this is your point load and it is denoted as W is the intensity of the load and the unit is kilonewton or meter, kilonewton or newton. This is not per Newton, it is kilonewton or Newton. Don't be confused. Then you have a uniformly distributed load. Second type of load is a uniformly distributed load. Uniformly distributed load means it is the load which is distributed uniformly throughout the span of the beam. So This is the length L in span, and uniformly distributed load is denoted by kilonewton per meter because it is di- distributed throughout the length. Okay, so per meter means the length you have to look here. And whenever we are solving any problem, first thing is to convert this UDL into the point load. So how you will convert the UDL into point load? You have a formula, that is the load into the length. Length means at what distance the UDL is acting. So load, how you will calculate load into, that is intensity of the load into the span, at what span it is acting. So first thing is to convert this into point load. Then third type of the load you have is the uniformly varying load. Uniformly varying load is the type of load where your intensity of the load is zero at one end and the maximum at the other end. Okay, so this is the uniformly varying load. This is denoted like a triangle, and whenever you are calculating the any reaction, the first thing is to convert this UVL into the point load. And here also you have one formula to convert the UVL into point load is the, and it is also denoted in the kilonewton per meter only because it is the two span. Okay, load is acting to the whole span. So you have to, unit is kilonewton per meter. And how you will convert this UVL into point load? So UVL into point load, to convert UVL into point load is the formula you have is a half into base into height. That is the area of triangle. So half into base, what is the base is L, and the height is your intensity of the load. So this is your load conversion from UVL to the point load. So till now what we have studied, point load, UDL and the UVL, and these are the very important part of this topic. So you need to understand this first, then only you will be able to solve the further part of the problems. Then same way for this also, this is given 45 degrees 20 kilonewton. This is 45 degree. Okay, so horizontal component will be 20 cos 45 and vertical component will be 20 sin 45. Understood? We have to resolve this resolve this load in the horizontal and vertical direction. Now first thing is to see what type of the supports it is given. This is hinge support. So hinge support you have two reactions, that is vertical and the horizontal reaction. So this is VA, this is HA. Okay. And roller support have only one, that is V. If this is B point, this is A point. Okay. Now we have to see now equilibrium condition. What is the equilibrium condition? Summation of VA summation of V is equal to 0. So summation of V is equal to 0. So what are the vertical reactions? So vertical we have, and sign convention, look here, upward positive, downward negative. Okay, clockwise positive, anti-clockwise negative. Keep in mind the sign whatever you are using. Now upward, what is upward reaction? We have VA, whatever, and plus VB. Then you have minus 10, it's going downward. What is the component of this? It is also going downward. So minus 15 sine 30, then second minus 20 sine 45 degree is equal to 0. Okay, now VA plus VB is equal to, I am taking all this term on left side, it will be positive. So what is the answer I am getting is 31.64 kilonewton. Okay, now okay, this part you understood. Then VA VB, we don't know VA and VB, so how to calculate VA or VB? By using the second equilibrium condition, that is the moment about A or B equal to 0. So the second part is moment about A equal to 0. To find out VA or VB, you need to calculate the moment. So moment about A equal to 0. So how to calculate the moment at this point? Moment will be distance load into distance. Okay, so first load what we have is 10. So 10, it is going clockwise direction. So 10 into 4. Then you have second, what is the vertical component of this is 15 sine 30 degree into what is distance from here to here, it is 2 plus 4 is 6. Then third is 20 sine 45 degrees into what is the distance from here to here is 4 plus 4 8, 8 plus 2 is 10. And last one is this reaction, and this is going in anti-clockwise direction, so minus VB is equal to 0. Okay, now calculate this. 10 into 4 is 40 plus 15 sine 30 into 6, you get 45. 15 45 plus 20 sine 45 into 10, you get 141.4, and VB I am taking this side, so it will be positive VB. So what is the VB you got here? Okay, VB into what is the distance I have not taken. From here to here, what is the distance? 4 plus 4, 8, and this comes to 12. Okay, I will be writing here again. VB into 12 is equal to 0. So VB into 12. So what is the VB now? Add all these things, you are getting 226.4 divided by 12. And what is the answer you got here? 18.87 kilonewton. So you got the VB. Now you have got the VB. Substitute in your first equation, that is VA plus VB is equal to 31.64. Substituting VB, you will get the VA. Okay, so both the reaction you will get from here. So what is VA plus VB is equal to 31.64. So VA will be equal to 31.64 minus VB. VB you got here is 18.87. Okay. So what is the VA now you got? 12.77 kilonewton. So VA you got is 12.77. So two vertical reactions you got, VA and VB. Now last is to find horizontal reaction. So how you will find out the horizontal reaction? Horizontal reaction you have one, that is HA. Here also you have sign convention. If this side is going, then positive and this side is negative. Now HA, okay, and both these reactions are coming this way. So minus 15 cos 30 minus 20 cos 45. Okay. So HA, take this on that side. So you got is 12.9 plus 14.14. So HA you got is 27.04 kilonewton. Now you got the reactions. VA you got, VB you got, and HA you got. So using the three equilibrium condition, you got the three reactions. So this is the statically determinate beams. In this chapter, we are dealing with only the statically determinate beams. So this is your final answer. HA you got, VA was 12.77 kilonewton, and VB you got is 15.87 kilonewton. So these are your final answer. Hope you understood this problem. So I will give you one problem for your homework. Please try to solve it. And if you have any query regarding that problem, please comment me in the comment section. So I will explain you in the next class. Now this is your homework problem. Here you are given roller support and this is a hinge support. One point load is given, UDL is given to you all, that is 30 kilonewton per meter. Other incline load is given you 60 kilonewton, point load is 20 kilonewton, and distance is 2 meter, 4 meter, 1 meter and 2 meter. Try to solve this. Please try to solve this problem, and those who have solved this problem, answer, comment me in the comment section your answers, and I will bring next part of the video will come very soon. So till then, practice well and bye bye. Take care.